Hello guys, welcome back. In this video we'll be learning about the types of fossils. Now fossils are the physical evidence of the pre-existing organisms. Now the evidence can either in the form of its body part still remaining, or it can be in the form of its activity which is still remaining, right? Now if the body part remains, right, it can be on the two parts. Either the organism soft part is still remaining or organism hard part is still remaining, right? The soft part remaining, it's very rare, right? Because it involves a perfect preservation, perfect burial. Okay, now we'll see what are some of the examples, like freezing. In Siberia, many times woolly mammoths are found completely preserved. On the other hand, we can also see resins which exhumed from the plants, right? So insects, some mosquitoes are found inside this amber, right? So 18 million old mosquitoes, right, in found in the amber in the China. Okay, apart from these, many times there are crude asphaltic oil which come out of the surface forming a pool, and when the animals they hunt prey, they are also trapped in this crude asphaltic oil. Crude asphaltic oil acts as an inhibitor. It prevents the organism's oxidation or organism's consumption by other prey, and hence lots of organisms are also found. For example, in La Brea tar pits in Los Angeles, USA, 38,000-year-old saber-toothed cat skulls have been found with their prey. Hard part preservation, the evidences are quite common. These parts are common because they are hard. The soft parts are normally either oxidized, normally either they undergo bacterial decomposition or eaten by the other animals, right? The hard parts, which includes the tooth, the bones, the horns, nails, etc., are found well preserved. Now these hard parts, they undergo petrification. What is petrification? Petrification is the conversion of the remains of the plants and animals into the rock. The internal organic structure as well as the external form of the preserved bodies remain unaffected. That is the organic structure, that is the organs, right? The organic structure. Okay, the bones remains as it is. There is no change in the shape of the bone or the shape of the tree trunk, right? But the bodies lose their original constituents, which are replaced by the silica, calcium carbonate, oxides or sulfides of iron, etc., right? Now in petrified remains of trunk of trees, the internal structure of the plants and their outer appearance remains unchanged, as I've already told, right? But the organic constituents are replaced by the silica. Petrification is a very slow process. It involves removal of each individual molecule of the material of the hard parts of animals or plants in solution, and simultaneous precipitation of an equivalent quantity of replacing minerals. The carbonization of the hard and soft parts. During carbonization, the parts are decomposed, it loses nitrogen, oxygen and other volatile constituent, and it gets enriched in carbon. Example, the coal seam, right? If we move to molds, the hard parts of the animals and the plants preserved in the sediments may also be totally removed in the solution, right? It's very much possible that the hard bones and the tooth and the horns, these get dissoluted in the water, right? And these hollows are left within the rock beds, and these are known as the bolts. Okay, those imprints of that scales are still left, and these are known as the molds, right? The molds in porous and the permeable rock beds, the subsurface water charged with the mineral acids can remove in solution the hard parts of organisms forming the molds, right? As I've already told, it all depends on the water. If the water is not so acidic, nothing happens to the hard part, but if they get removed, they get dissoluted, right? Now when these molds are subsequently filled with the mineral matter, it gives rise to the casts, right? So cast, as I've already told, it's an internal filling, right? And the organic, the structure, the shape remains same, right? Example can be, a wood which is petrified, as seen in Kadalur, ammonoids, right? Molds are the external fillings. For example, Archaeopteryx imprints found in the Jurassic rock 115 million years, or for example some leaf imprints or some animal imprints which have been marked and imprint on some argillaceous rock, some shale, right? So mold is external filling, cast is internal filling. Now, as I've already told, the fossils are the physical evidence of pre-existing animals. These physical evidence can either be the direct remains of the fossil or some of the activities which fossil did at its time it traces. Now, based on the biological activities preservation, the trace fossils are also known as the ichnofossils. Now, the trace fossils, the activities can be divided into 4 parts. First is the habitat and the movement, right? Now, if a bird dinosaur, Archaeopteryx, it moves, it will create footprints, right? If it, like a snake moves by dragging itself, it creates trails, right? For example, the worms. And if there are burrowing animals, they cause the bioerosion, forming the tubes and borings. Burrows and tubes will be formed. The second, activities and its traces can be found with respect to the nutrition. For example, the coprolites, which is the excreta, right? The excreta, we can study the feeding habit of the animals, right? Whether the animal was a vegetarian or the non-vegetarian animal, at what height the animal consumed its food, so on and so forth. The second is the urolite. It's actually a soil erosion formed when liquid waste is excreted, forming to the deformation of the nearby soil, which is quite characteristic. Even if today some of animal with that very same height, it urinates, this kind of soil deformation occurs. So this is known as the urolite. The next is the reproduction. Now, reproduction, we have find the fossilized eggs of the dinosaurs, right? The shelled fish eggs, okay? Apart from this, we have also found, quite interestingly, the preserved sperm of the whales, okay? Now, finally, if we move to some of the quite unusual fossils, that are the associations. Lots of animals are found associating with other animals because both are, kind of friends with benefits, right? For example, one of the symbiotic relationship is with the tertiary gastropods with that of bryozoans, right? The bryozoans are quite equivalent of that of the coral reefs, but they are different kind of phylum, right? So suppose this is here a gastropod, what you see known as shank, right? So this is a snail here with its 2 eyes. It moves. Okay, now bryozoans, they attach to the outer shell of this gastropod. By the term gastropod, I mean the gastro, it means the stomach, and the pod is like pad, means pair. Okay, so an animal which moves on its stomach. Okay, so these bryozoans completely cover the outer shell of this gastropod, forming a cushion. So the gastropod gets an extra advantage of protection, while the bryozoans, since the gastropod moves to some new location, this locomotion lets the bryozoans get newer access to the foods, right? So let's summarize our types of fossils. Our fossils can be divided into two parts: the body part and the trace fossils. Body parts are again can be divided if the whole body is preserved, including the soft parts, which can be either in the ice, can be either in the amber of the trees, or it can be on the soil in crude asphaltic oil, right? Or the whole body can be preserved because of some internal fillings forming casts, and because of the external fillings, which is the mold. The activities of the organisms can also be seen and recorded. For example, its movement in the form of footprints, trails, burrows and tubes; in nutrition in the form of coprolites and urolites; in reproduction in the form of eggs and the sperms fossilized; and in fact in the form of association, for example the bryozoans and gastropod association, right? That's all. Thank you.